Hello everybody, this is Mr. Shaban. Today we're going to complete the separation technique unit. We have taken last time the difference between mixture and solution. We said mixture is when we put more than one substance together, and one condition, they should not be chemically combined. And we took an example, air is a mixture which contains nitrogen, oxygen and small other gases. And we have taken solution is a homogeneous mixture where it contains solid dissolved in a liquid. We named the solid as solute and we named the liquid as solvent. And then we have taken the meaning of a saturated solution. We have taken how the temperature affects the amount of dissolved solid, and we have taken that when the water is acting as a solvent, we call it as an aqueous solution. Then we have taken different kind of solvents, ethanol and propanol, and then we have spoken about one way of separating the solids from liquids, which is filtration. And we have taken another examples like decanting and centrifugation. Today we're going to complete separation technique, and this time we're going to talk about how to separate a soluble solid from salt solution. At the beginning we have the crystallization. This crystallization is the first method in order to separate dissolved solid from a salt solution. And in crystallization, you're going to do the following. You're going to heat the solution until the solution temperature increases, and then you should add the solute. You should dissolve as much solute as possible to make a saturated solution. When you make a saturated solution, heat the solution to evaporate some of the water. It becomes more concentrated or saturated. Eventually the solution becomes saturated. When it reaches to that level, when you heat it until you have a saturated solution, then you take it away from the burner, benzene burner, and let it cool until the temperature drops. And you need to let it cool to make the crystal start appearing and to form the crystals. Check that it's ready by placing a drop on a microscope slide. You'll see the crystals will form quickly on the cool glass. Leave the solution to cool down. Crystals start to form in it, and as the temperature falls down. Then you remove the crystals by filtration. Then you rinse them with distilled water to make that you have a pure crystal, and then dry the crystals with filter paper, not in the oven, to avoid loss of water of the crystals. So in crystallization, it's based on 2 points. The first one is to make a saturated solution. Make a saturated solution by heating up the liquid. Add as much solute as possible, and then you let it cool down and you let the crystal form. The crystals are the solid but in a larger form. These crystals contain some of the water, that's why they have enlarged sizes. And then you let it cool for 2 or 3 days, and then you take the crystals, wash them with distilled water, and then dry them with a filter paper. We have a couple of hints over here. The first point, why crystallization occur? Solubility of most solute decreases as temperature decreases. So as the temperature drops, the solubility will decrease. So when solution cools, solution can't hold more solute. So the extra solute separates as pure crystal. We have something called point of crystallization. Point of crystallization is a point where the saturated solution is obtained. So when you have a saturated solution and you let it cool, this is the crystallization point. Saturated solution is a solution that cannot dissolve more solute at a specific temperature and a specific volume of the water. We have another method in order to separate a dissolved solid from liquid. This method is called evaporation. So in evaporation, we get evaporating basin. We put, like as an example, salty water. Salty water is a salt mixed with water, dissolved in water, and then we heat it up. You're going to find that the water particles are going to evaporate, leave the solution, and then we're going to have salt as a remaining at the evaporating basin. To obtain the salt from aqueous solution, you need to keep heating the solution to evaporate the water. When there is only a little water left, the salt will start to appear and heat carefully until it is dry. So that's another way of separating the soluble solid from liquid. So we have taken crystallization, we have taken evaporation. So crystallization, we separate soluble salt from a solution. Also evaporation, we separate soluble salt from a solution. Then we're going to complete with the next method of separating the mixture, which is separating a mixture of two solids. When we have two solids, as an example, sugar and sand, and you want to separate sugar and sand, you need to keep in mind, to separate them you need to have one which is soluble, the other one is insoluble. So what you're going to do is you get these two solids, okay, and then we're going to add water to the mixture and stir them. When we add water and stir the mixture, the solid which dissolves in the water is going to dissolve and the other one is going to remain. So we dissolve the soluble solid first, then we filter the mixture. After we dissolve the soluble solid, we filter the mixture. When we filter the mixture, the undissolved solid, which is sand, will be trapped in the filter paper, and the dissolved solid will go through the filter paper with the water. Then you're going to rinse the sand with water to make sure that it's clean, and then you dry it in the oven to get the sand pure in one side. Then when you have the salt and water, you're going to evaporate the water in order to get the salt out of the salty solution. So in this method we are doing some steps. You need first to make sure that you have one of your solids is soluble. You take this soluble solid, you dissolve it in the water. You're going to have one of them dissolved, the other one is going to remain in the container. You separate the undissolved solid by filtration, and then you rinse it with distilled water and dry it in the oven. And in the other hand, you take the filtrate, which is the water along with the soluble salt. Then you're going to heat it up in evaporation process, and then you're going to take the salt out of the salty solution. Note, water could not be used to separate the salt and sugar because it dissolves both. So when you do this step, you're going to dissolve both the salt and the sugar, and you're not going to have anything to be blocked at the filter paper. But you could use ethanol, which dissolves sugar but not the salt. So over here we need to find another solvent, and in this case we're going to use ethanol, because ethanol dissolves only one kind of solids. It dissolves the sugar but not the salt. Ethanol is flammable, so should be evaporated over a water bath, and this is very important. Flammable means it can easily change into gas, and if you're using benzene burner it might fire up the whole thing. So in case you are using ethanol and you want to heat it, you need to heat it in a water bath. Water bath, it means you get electric heater, and then you place a large container which contain water. You heat the water, and then you put the tube which containing the ethanol inside the water. So you're heating the ethanol by the help of the hot water. That's what we call water bath. The second method of separating a mixture of two solids is separating as pair the magnetic properties. So if we have like two solids, one of them is magnetic, the other one is not magnetic, like sulfur and iron, sulfur powder and iron filling. The sulfur is not magnetic, but while the iron filling is magnetic. So when you apply a magnet, the magnet is going to attract the iron filling from the sulfur powder, and this is going to separate the iron from the sulfur. So we can separate the two solids as pair the magnetic properties, as we have discussed over here. Then we're going to talk about separating solvent from a solution. So how to separate a liquid or a solvent from a solution? We tend to use a separation technique called simple distillation. So as you can see, this is the apparatus of the simple distillation. So over here we have a rounded flask where we're going to keep the liquid, and this is what we call condenser, and over here we have a conical. So this is the water in, where the water gets in, and this is the water out, where the water gets out. What we do over here, we get the solution, we heat it up. When we heat it up, the liquid is going to evaporate, change into gas, and it's going to move up until it gets over here in the condenser. In the condenser we have a cool water cycle. We have two tubes. The water gets in the outer tube and nothing gets inside the inner tube. Inner tube will accommodate only the gas or the vapor that comes out of the liquid of the solution. And the outer tube is going to have a cold water circulation where it's going to move across the inner tube in order to cool this particular vapor. So vapor goes, evaporates, and then gets inside the condenser, and then the water will circulate around the inner tube in order to cool it down. Then when you cool the vapor down, it's going to change into liquid, and this liquid will be collected in the other side, which is the conical. So this process is called simple distillation. The apparatus is shown below. It could be used to obtain water from salty water, and you make sure that we are looking for water, we are not looking for salt. If we are looking for salt, we would have done evaporation, but we are looking for water. So we heat the solution in the flask. As it boils, the water vapor rises into the condenser, leaving the salt behind. The condenser is cold, so the vapor condenses to water in it. The water drips into the beaker. It is called distilled water, or most pure form of water. You could get drinking water from seawater in this way, because seawater is going to have salt and water. So water evaporate, leave the salt behind, and then it will cool down to change from water vapor into a liquid. So this way is how the countries in the Middle East can obtain the water from a salty water. In today's lesson, we have gone through different techniques. We have gone through how to separate the two solids out of each other. We said if it's based on solubility, we'll get two solids, one soluble, one insoluble, and then we put water to dissolve the soluble, and then do the filtration to remove the insoluble, rinse it and clean it and let it dry in the oven. And to get the soluble, we evaporate the salty water or the solution to remove the salt out of the liquid. Or we can separate two solids as per the magnetic property. If one of them is magnetic, the other one is not magnetic, we apply magnet or magnetic field, where the magnetic field is going to attract the magnetic substance and leaving the other one unattracted. And then we have spoken about the separation of solvents from solution, and we have discussed how we can use the simple distillation in order to remove the liquid out of a solution. I hope you have enjoyed today's lesson, and see you next time.